Partial completions. In this stage, you'll extend auto-completion to handle partial completions using the longest common prefix logic. Completing to longest common prefix. When multiple executables match the user's input and some are prefixes of others, your shell should complete to the longest common prefix of all matches. For example, if these executables exist in path, so xyz foo, xyz foo bar, xyz foo bar baz, when the user types XYZ and presses tab, the shell completes to XYZ foo because that is the longest prefix shared by all three executables. After the user types the next separator character, pressing tab completes the next common prefix of the remaining matches. Ooh, okay. So that way I can switch and go through all of them. If there's only one match after performing completion, then the shell should complete the command name as with previous stages with a trailing space. So this would then let me do the tab into bash and do the fun stuff there. How do I want to do this? I need to track what the last command that I tabbed was, because each time that I'm hitting tab, it's another thing through the loop. So it's not like I can sit there and go over and over again. I still want the tab error. Wait, is that true? Do I not want the tab error? Oh, okay, so I don't want the tab error. We only do the tab error if I don't find anything at all. So, is that true? Yeah, okay. So there's no bell unless there's nothing to match. This one I'm curious about, because isn't this mean that a lot of this stuff that I'm doing just won't happen anymore? Because it will never display the things that I'm going through the way this is set up, which is fine. I just want to make sure that I'm doing it right. Because in this case, I guess we have a tab error if it can't find anything at all. We push this up in a commit, so I can always come back to this again. So I almost feel that this becomes an else again. Oh, not whatever. Don't use a mouse. So I feel that this becomes an else again. I want to take this and maybe make a const up here. So const bell, and you're a stir equals you. Okay, so I can easily find that again if I need it. All right, so we hit tab. I need to find what the potential matching characters are. If I hit tab, I also, okay, so we need to track outside of our loop what the potential matches are. So matching commands, and this will have to be a vector like that. When I type into it, I want to clear that vector out because there's no more typing, and I need to tab autocomplete again then. So matching commands, we clear you. When I hit tab, it finds the matching command. If there's one matching command, it does that. Well, that doesn't seem to be right either now. Now I feel like I want to find I feel like all of this is gone. And I just want to let possible matching commands equals find executable files. This is the current input. We get the path. It's true for a partial match. Now we get a vec of these. If we have the current, I wonder the longest common prefix. So I need to either reduce it or sort it by how many are like comparable. I actually haven't ever looked at like an official algorithm for this. I'm sure that there's good ones to like go and just sort of grab myself. But if I were to implement this, one of the first things that I go into is almost use the idea of a system where I create a separate vector that's the same length, so I can map it and then count the number of common prefixes. Like how many letters do you share that's together? And then I can't sort that, but I could find the index of the largest one and then grab that one from the list. Or I can map and create a tuple. Yeah, map with a tuple might be better because then I can sort. And then all I need to do is track for each tab press the current index that I'm going on, that I'm using. That might make sense too. So I only need to get the possible matching commands if we're empty here. So if we press tab and our matching commands is empty, then go ahead, get the path, get the possible matching commands. And then I can do, before I even save that to the matching commands, I should I should map and sort this. So this is going to be, what do they call this? Longest common prefix, so LCP. So this is matching commands with LCP. I'm doing sort of long names here, even though I probably don't need to do that. I might be able to just one line this, or just like chain this a little bit easier later. But this is a learning project. So if we take our possible matching commands, I into iterator this, I then map you, and so I have a dir entry. We're probably going to do a couple of different things here. So first, I probably just want to turn this into a bunch of strings. So let's map filter this. What is it? Filter map. Filter map. So we take a dir entry, and I want to get the file name. I want to turn it into a string, convert that into an option. Okay, so now I have just the file names as strings. I then want to map. So now we have a command name. What do we want to do here? I want to check to see how many letters. So I essentially want letter count from the command name. So do I get anything like that? Because obviously there's a contains. There's compare, but that's just equals equals. Okay, so there's nothing here that I'm gonna have to write this myself, which is fine. That's sort of what I expected. I should probably create a separate function for this. All right. We're going to eventually, so let's create like a placeholder for this. Or actually, I create the function here. So pub function. This is going to be get LC. Is it LCP? Yeah, get LCP. I don't want to. I want to call it longest common prefix. So longest, or not. I can just call it longest. I don't need longest common prefix. I need common prefix. Oh, and it's prefix. Interesting. So we are going to probably do starting with common prefix sort of count. We're going to take in like the full word, and then we're going to take in the prefix, and then we count that and just sort of see how many letters that is. So it's going to be two stirs that we take in. We want the prefix, which is a stir, and we want the full word, which is a stir, and we're going to return probably a U8. I mean, I don't think there's very many commands over 256. This should be fine. To do that, I forgot how to use jumping around in Helix. Okay, so in this case, I can return a tuple of command name, and then the other thing is then the value of this, which is going to be common prefix count. So matching commands, I want to collect this into a vector of tuple, so string and U8. Okay, that gives me you there. Path, I forgot to question mark you. You are upset because I forgot to actually call you as a function. So our prefix is the current input and command name. Okay, there we go. So that gives us our matching commands. I could then store that up. Along with, I guess then we sort it. Then we sort this. That was a thing my brain did. Okay, so we matching commands with LCP. We need to sort, but we need to sort by sorts the slice and extending order with a comparison function, preserving. Oh, there's no more examples. I do compare, right? Okay, I think it's compare. So sort by. We have A and B, and then I want to A dot one compare to B dot one. I think that's how it works, right? Expected a reference. Okay. Okay. So if I compare that, then we should get it in an order, and then I can just loop through the vector, just increment the index and go from there. Of course, that other function isn't written yet, but that shouldn't be too terribly hard. Um, we are going to need to update you. So instead of contains, we're going to starts with. Yeah, is some and starts with this. That will just sort of help things out because some of those didn't even begin with like, bash didn't start with B or A. And so it would just have a 0 and that would cause problems. Okay. Yeah, you need type annotations, but we're going to be giving that to you shortly. In fact, I think at this point I can save it, right? So we have our matching commands equal to now matching commands with LCP. Our command name got borrowed. Cloning here. That's fine. That does make sense. If I'm putting the full string into here, I also need to clone you. Okay. I mean, I guess I could get the prefix count ahead of here. That would make it so I don't have to clone. So I could do let prefix count equals our common prefix count. Oh, but that's a function name. Okay, so I give you that. Then I return. I don't need to do this clone anymore, and I can return prefix count, except without that comma there. Okay, that makes a lot more sense. Just order of operations. I store that. I need a let mute. So this is gonna be matching command sort of index. So to track where we're looking, having this be its own struct might be a thing that we want to do. Yes, I know it's unused. Don't worry. Okay, so we get to this point. We set you, and then also we set our matching commands index to 0. So we reset that. When I hit tab, I want to clear the line and put the thing that we're on in there. So matching commands is empty. We just sort of set that all up. If our matching commands is still empty, after this, we probably print a bell. So matching commands still empty. We're going to print the bell, and that's it. We don't do anything else, which means we can, I don't want to continue. So I need then an else. Okay. So matching commands is not empty, which means that I can clear the line. We print the prompt. I want to print the command, the matching command. So print, and this is the current matching command for the index. And then we increment the index or reset it. It has to like go back down to 0 if we go above it. So we'll have to add that logic in too. So we're gonna have matching commands of matching commands index. Okay, so we print that. We increment the matching commands index. So let's do this as matching commands index equals if the matching command index is equal to matching commands length. Okay, so if it's equal to length, that means it's too large anymore because we start with 0. So we want to return 0. Otherwise we return matching commands index +1. And so that's incrementing that. So we're now looping through. I mean, we've done a lot of code with very little testing. The chance of this working is really low, but and also a pretty good chance that we'll be sort of like, oh, where is it going wrong? We'll have to figure that out. But let's get this common prefix count going here. So for this word, I just want to count how many letters it matches with it. So I could actually reduce this, but we can break early as soon as we don't see it. So what if I have let mute? So our count, we start with 0. We're going to return our count. We're going to loop through each character. So for our it's like word character in word.chars. Is this right? I'm looping through each word character and then wait, this is probably not right. I want to loop through an index of them. So it would be index in a range of 0 through word.length. So this would then allow me to get the character in the word, and then we check it. So if the prefix of index is equal to the word of index, then count plus equals to 1. And if it doesn't, we can break early. And then we just return the count. Cannot be indexed by usize. Oh, I was hoping I could index this. Let's see. I can split them, can't I? And then I would be able to. So I can split the prefix and I can split the word up. Is there a way for me to get by index though? Ooh, returns a subslice of string. Let's see. Can I get? They have an example here. I want 0 through 4 gives me that. That's not inclusive. So if I wanted, oh man, we haven't used this in a long time. The Rust playground. Yeah, this is whatever I was doing last time in here, which we do not need to do. So let's have a string. So let word equals hello, and then I want to grab the first character, right? So that first character equals word get, so 0, 1. So that's not inclusive as 1. And then let's print line first character. Oh, that gives me an option. Oh, interesting. Okay, so that did give me that. So if I looped through, so if I created a for loop, so if I did for index in 0 through word dot length, then I could grab letter first character. Showboat, hello. Is there a reason you're using the playground to code? I am just testing some stuff out here before I go back into the main code because it's a little bit easier. Also, how are you doing? Okay, so if I get, this is really just a word char. Oh, I can move that in like that. So on a print line, my word char, because this would allow me to then do my comparison the way I want it to. So I can get all of them, except I don't want that. I want to index. Ooh, but I want index -1 like that, don't I? You didn't like that. Because I don't want 0 because it will give me everything together. So how do I get... Oh, because that starts with this. It's actually index to index +1. Opposite. There we go. That's what I want. Okay. And it is options. That's good to know. So back to our code. So if we're getting the common prefix count, I now have the index for the 0 through the word through length. We can't index this like a vector. I could split it, but why would we do that? Although if I could only have to split one of them and I can enumerate to get the index, that might actually be faster. So what if I word char in word dot chars dot dot enumerate. So that gives me, enumerate gives me the, oh, let's not do any of these yet. Oh, this is weird. I need to do that. Okay, there we go. Backwards. So we have index, stop, nope, bad. And then this is the word char. Okay. So if I do that, now we can check to see if prefix, so we need to get. So let's this is going to be the prefix char equal to prefix dot. Now I get from index to index plus 1. If I don't get anything at all, we're done and we break. Now I can check it. If prefix char is equal to the word char, then count plus equals to 1, and then we continue on. And eventually we break out or we run out of letters, and then we return the count. Let's see, prefix char is, I want to, wait, I can't dereference. Oh, it's prefix char I need to dereference. Prefix char is a string. Wait, what are you? You're a stir. Oh, and you're a character. That's why. Oh, because get is a character. Even though I know that you're one. Is there a way for me to check? I can word char as a stir, right? Oh, but because a character might not be a string, I could to string it. I think that would work. Yeah. Okay. Okay. So let's see. All right, this is in my utilities. Okay, so if the matching commands is empty, we print the bell. Otherwise, we clear the line, we print the prompt, we print matching commands, matching command index, string U8, 0. Okay, that was a lot of code. That feels wasteful. Oh god, that is horrifically wasteful. We should definitely not have to turn this into a string to just check that. There surely is a much better way of doing that. I do want to test to see if this works, and I know that at least 2 strings should do the thing. So if I cargo run this, if we type, I guess let's just check to see if we still have oh no, I don't think if I do echo, we lost. Okay. I mean, that kind of was interesting. Hold on. If I do bash, base name, bash bug, base 64, bash, bash language server. Oh, and then I run out and I die. That's okay. We got index out of bounds, but the length is 6, but the index is 6. Oh, okay. So we're actually, it's kind of working. It's kind of working. Looks like we have a break coming up in 2 minutes. We'll see if we can get this done beforehand. I can actually snooze this. I have 3 snoozes total. So, okay, map. Okay, so if my matching command index, oh, this is wrong. If my matching command index plus 1 is equal to that, then 0. I think that'll make it work properly. So cargo run. So if I do bash like that, base name, bash bug, base 64, bash, now I continue going over forever. So perfect. That's great. I did lose find matching command. I feel is no longer what I want this to be. I think I want this to be find matching built in now. And find matching built in, I kind of want that to just go in with the others, don't I? Or do we try these first, and if none of them matches, no, because now I want to partially, I just want to go through and like you don't know if it's a built-in or not. It doesn't matter. I feel like we're not going to need find matching command anymore. So let possible matching built-ins. We're just going to built-in command matches. Okay, built-in command matches are partial, which is the current input. Okay, so now I have a vector of potential matching built-ins. I get these dir entries. I filter map these into strings. I want to add in. So can I, with an iterator, can I add things into this? I don't know if I can with a vector. So I've turned this into a vector of strings. If I could not zip, I want to append. I mean, yeah, it's true. The strings are small enough, so it shouldn't matter. It's not like I'm doing like an entire the contents of files. But it does also feel like, come on, do we really need to? Like a shell should be fast, even though mine is append, inserts. I don't know if there's anything I can do. So zips up two iterators into single iterator of pairs. I don't want to zip it. I want to add to it, but I don't think I can. So I think I would have to collect this into a vec of string. So talk about not really all that great here. And then I can concat. So flattens a concat flattens a slice of t into a single value. Oh, that's not what I want. I want to append, moves all the elements of other into self, leaving other empty. I am perfectly fine with that. So append, I need to, this is the possible matching. Okay, so possible matching built-ins, and then into iterator again. Wait a second. You don't return anything. Oh, so I need to end here. Does this give me matching commands equals that? I could then matching commands. I have matching commands here. I don't want that. Matching commands. This is combined. So combined matching commands. Let's do another snooze before I forget. Combined matching commands into iter filter map collect is that I then append the possible matching built-ins. You need to be mutable now. And then we take our, we have to do this again. So we do let our matching commands with LCP is equal to our combined matching commands into iterator. Okay. We do have two errors in here. Mismatch types. Okay, so matching commands equals this. Expect struct. Spec of string. I did this. Should be combined matching commands. Matching commands with LCP. Cannot borrow as mutable. Okay, so I need to make you mutable. Okay, we don't have any errors anymore. So I mean, I could run stuff now. That's cool. If I run this again and I do echo hello world. Oh, interesting. Um, it lost the line because I didn't add into current input when I accepted it. Because as soon as I hit space, I need to note down like which command we're in. And I wonder if we should just mark that as our current command then. Because that might make sense. If we tab, okay, so when we tab, we clear the line, we print the prompt, we print the matching commands, index of that, matching command index, we update the matching command index, and then we need to do our current input is equal to matching commands, matching command index 0. Sure, I'll clone you. Why not? We're already doing so much other cloning. Why not do that? Okay, no, everything's saved. Okay, so we do this again, and I do echo hello. We get hello. If I do type echo shell built in, now how do I know which one I'm actually running? Am I really running that? I don't know. Like if I do, oh, I did CD and I lost it. I mean, this might kind of work. I'm not 100% sure, but I think it's kind of working. Because if I do ls source, like everything else still does what it's supposed to do, which is cool. I want to find out whether or not this works. I also want to save this. So let's just see. Maybe correctly. What is it called? Like looping through tab options. Let's find out. What's the chance? Okay. Failure. So running tests for auto completions, partial completions. Okay, so it received the prompt, it typed XYZ, it matches, it pressed tab, expecting autocomplete to XYZ ant, but it got XYZ B rat. Okay. So my algorithm to figure out what the number is incorrect. And then I think for debug purposes, where should I put this? I print U, I do that. I kind of want to, okay, let's clear the line. Let's just do a print line of the matching commands, that. And then I can see the order of it, and I can also see what the numbers are. And obviously we know what we're trying to match too. So I saved. So if I do bash like that, base name is 3, bash bug is 3, base 64 is 3, bash. Okay, so I think I've got this wrong. I think I've got my algorithm is definitely wrong for creating the LCP. I think it's supposed to be higher number with we're supposed to do something about like the total length of the thing that we're matching for, and that's not what we're doing. I'm just counting how many of them. Maybe it should be how many are remaining. Maybe we should do how many are remaining. So I count 0. What if they're equal to this, I don't do anything, right? So if they're okay, so if I've run out of prefix characters, I don't actually break. I'm probably not going to get this done. I don't have any more snoozes left on the ad. So I think what I'm going to do is I'm going to click start now. The ad break will start in like a minute or so. We'll take our break and then we'll come back for the last hour and see if we can get this common prefix count to be what we want. So if I type in BASH, I want the number of letters that are remaining. That's all I want. Because if I typed it in exactly, that should be 0. If there's like one remaining letter, that should be 1. So I can maybe remove. Actually, we all know that these start with it, don't we? They all have to start with it. Although I suppose we don't really know that for certain in this function. Like if I wanted this function to not make any assumptions, I need to remove the prefix from the word. Once I remove the prefix from the word, then I get a count. Okay, so common prefix count. So actually, so this assumes that the word shares a common prefix with the prefix. So we're going to return the number of remaining letters in the word after the prefix is removed. Okay. All right. Welcome back. I think we figured it out, or at least I'm pretty sure we have. We're going to remove the prefix from the word because that's in there, and then so which means I need a slice. So if we just need to restart with this. The count might be fine. Actually, I don't think I'd even need the count. I think it's going to be simpler than that. So I need to get the slice of the word starting with prefix. Let's actually come back to here. So we have word, we have let our prefix equals, let's say we have that. I don't need you to be a string. I need to then grab the word without prefix is going to be word dot get. It's not 0. It's going to be prefix dot length to the end. And then we're going to print line word without prefix like that. Should probably semicolon. Okay, so I removed HE and I got LO. Okay, perfect. Then I can count that. All right, so we're going to remove the word. So, and I think this should be fairly simple here. I wonder if I could do this all in one go, where we just say, give me the word. We're gonna get. If I unchecked, I really okay. We just want to get. We're gonna start with the prefix length, get to the end. That gives me an option. So I want to unwrap or else, unwrap or default, which gives me an empty stir if it's default, and then give me the length. And then this is a U size now. Okay, so common prefix count, that's what I care about. Before I do anything else, let's just run this again. Ooh, errors. I do have an error. Right, you're a U size. Okay, so if I bash like that, bash is 1, base 64 is 3, bash bug is 4, base. Okay, I like this. This is a lot better. Cool. Okay, so let's send this on up and see if it works. So correctly calculating the LCP. Ah, okay, it failed. Oh, yeah, yeah. I shouldn't really print those out. That causes problems. Commit. No longer printing the possible commands out. Okay, what happened? So this isn't a partial completions. We received the prompt. They typed XYZ underscore. They pressed tab. It auto completed to XYZ rat. They typed underscore and pressed tab again, expecting it to autocomplete to XYZ rat B, and it got rat B fox, which it should have done that because when we reset when we reset the matching commands, I also need this is the only place. When I reset the matching commands, I also need to reset the index. Just sort of blindly solo testing in. I mean, it's not production really, just running their test on it as opposed to mine, but we'll see if that. Oh, okay. Did not work. I was hoping it would. Okay, so what happens here? So everything is fine. So prompt line matches XYZ al. We typed underscore, and then we press tab again, and we want al cal, and we got al cal rat. Now, when we get the character in, we do clear the matching commands and a matching commands index, and we get these with every tab. So that is empty. It would be empty the next time we press tab, so it would figure this out again. I feel like it's let's see. Can I wonder what the best way for me to test this is. I feel like there's too many things with bash. Also, every time that was interesting too. Hold on. So when I did that, when I hit backspace, it doesn't know what I'm in. It went to the previous one. So if it's not empty, we clear the line, we print the prompt, we print the new command. So let's just say new, let's see, possible match command, matching commands index 0. I then can print the possible match command here. We reset the matching commands index. Oh, yeah, because I get the next one. I've been setting the current input to the wrong thing. So this is set U to be the possible match command. To owned. Oh, but you are a string, so I own it. Cannot move out of view. So yeah, I do want. Oh, okay. Get a slice of you, and I do need to own you. Okay, so now I don't lose you. And part of me wonders if that would just work. So fixed a bug where we were off by 1 for the user command, user input, when tab auto completing. Ah, okay. So same problem, XYZ ant, okay, so we did get to XYZ ant cow. When we did, okay, next problem. When we went to XYZ ant cow underscore and we pressed tab and there's only one choice, it wanted a space to be added in. So if there was only one choice, so matching commands is not empty, which means I need to see, okay, so let possible match command equals if matching commands length, so hold on, if it's length of 1, if I put this in here, I might actually be able to get away with now just saying if matching commands length is equal to 1. So we know we still have something in here, but there's only one thing. Then possible matched command, we push a space. Right. So you know what would make this a little bit easier for us? Let's not do this here. Let's not do that. What if we actually take our current input and we just set this now? We just set the current input to be the next thing. So this becomes matching commands. You're going to yell at me, aren't you? Maybe. Print, then current input. Cannot move out. Okay, so here we're going to clone you out. That's fine. Then we're going to say if matching commands length, I'll go down there. If matching commands length is exactly equal to 1, so if there's only one thing this could be, current input push a single space in. And I think that'll work here. So if I want, because there's echo art, there's so many different things. Okay, that added that in. Oh, because there's those, so I could add the space myself, or okay, I think I got it. So, adding space if there is only one possible match when tab auto completing. All right, let's see if this passes it. Okay, we got past that. Okay, so partial completions fully working. Multiple completions now. All right, so what is it doing? And this is the thing where I'm now confused about, like, how do I handle multiple completions? So they run a program, they get the prompt, they type XYZ underscore, they press tab, they expected a bell to ring and XYZ to still be there. But this works. They type XYZ underscore. Okay, so wait. Available executables. So XYZ underscore. They have pig, dog, and owl. Here they have ant, pig, owl. They could still be any one of these. This I'm confused with what they want me to do. Is the difference that these all have different LCPs and that these are all the same length, so they have the same LCPs, and so therefore we don't know what to do? This one I'm a little bit confused on, like how am I going to make the change to it to pass this test and also pass the previous test? And looking at the pattern, the only thing I can see is these are different sizes. So they typed XYZ, and then you have ant, pig, owl, XYZ, and then it's not like multiple different lengths of executables. These are partial completions too. The definitions of it are a little bit odd. So if in here, what did you want me to do? To stay the same, so nothing happens, only ring the bell, not if matching commands is empty, but if matching commands all has the same LCP. Let's see. Let's see. The type system will make that a little bit weird to put down there, but if I count you, there's an argument now for making this a struct because of this. So it's not is if empty. So if is, I guess it's both, right? So if matching commands is not empty, so let's do it's not empty and matching commands. Oh man, I'm gonna have to reduce this, aren't I? That's the reason why I need to do another file. Or sorry, another function like this. So if I do pub function and this is all common, I guess I'll just call this a reducer so we know it. So it's reduce LCP the same. It's a long function name and I don't like this, but we're gonna take in a matching commands, which is a slice of tuples of string and usize, and we're just going to return a boolean. I can just for loop through this. So for matching commands, we have that. This is going to be the word, which I don't care about, and then the LCP, which I do, and I need to know if they're the same. What's the best way for me to check? If I reduce out, we know that they are ordered, right? We know that it's sorted. So if I just check the first and the last, and if they're the same, so if matching commands, if the first one is equal to matching commands, if you're equal to the same, you have the same LCP because we're ordered. Okay, I'm not unhappy about keep putting this down here as a function. It's not great that it's like in this general utilities. It should probably be more associated with like these matching commands and like tab autocomplete. So that probably should be its own struct. Where's our if? So if, okay, so if matching commands is not empty and all matching commands LCP are the same, then we print the bell. Otherwise, we do that thing. I don't know if I have any commands that I can test that easily. I could set those up. I could set up these commands like that. That wouldn't be the worst thing in the world. Or I could just send it. So this is ringing terminal bell in case that all LCP are the same. I personally think that this is purposely making my terminal worse. Okay, partial completions. We failed here now. So we had XYZ Fox Pig underscore expecting autocomplete for XYZ Fox Pig Al. Yeah, that should have done Al. There was only one autocomplete left, so it probably rang the bell. So this also is if matching commands dot length, if this is equal to 1, then I get a return early that it's not, it's false. Fixing bug where auto completing when there was only one choice rang the bell. Let's see. I think we got less far this time. Oh wait, no. We fix. Okay, so we're done with partial completions again. We're back to multiple completions where it expected. Oh, it expected that thing again. It expected the double tab thing. I'm like so confused about why we're doing two completely different auto completion systems at the same time. I kind of wish that they didn't do that. Okay, so we need to track if we're in bell state. So we need to do that again. So that mute in bell state. We begin false. So if we get to this thing and we print the bell, then we also now have to check if in bell state we do something else. Otherwise, we print the bell and we go in bell state equals true. If we're in bell state, we're gonna have to fix this state. Otherwise, we'll constantly sort of getting in weird things where it's like, oh, we're in bell state or not in bell state or something like that. But if we're in bell state, I want to get all the matching commands, all the potential matching commands. I want to mix them together and print those out. So, what do? We print a new line. We print a new line, then we print all the potential matching commands. So we can just print a line. We want that displayable matching commands. I guess I probably don't even need to do that. I can just do this here. We have matching commands. We're going to join with 2 spaces. We then print one more line. I think we could just get away with that. Right? Join exists. Oh man, I can't join. Oh yeah, I can't just join because I need all the matching commands. So we have our commands equals our matching commands hitter. We're gonna have to map you. So we have a command. I just want command dot zero. We could just clone you at this point in time and collect you into a vec of string. I could, you know what? I can make you as stirs because the original ones still exist. So as stir, collect you, not whatever that was, collect you into stirs. That gives me a vec of stirs. The join method on commands. Okay. So then that does that. Okay, so we print all the commands out. I do another new line. I print the prompt. I print the current input, and also in bell state false. We're no longer in bell state. I'm not sure how to test this again because I don't have. I guess I can create these 3, like XYZ, dog, fox, and pig. I guess let's do that. Let's head into my home directory bin. Okay, so I have test program 1 and 2. What if I just move test program 1 to XYZ dog? Move test program 2 to XYZ fox. Copy XYZ dog to XYZ deer. That gives me 3 of them to go with. I want to, nope, not that. I want, come on. How do I go over to the other one? There you go. Okay, cargo run. I want to X, Y, Z. It's going back and forth between all of those. Oh, because deer has the same number. Move XYZ deer to XYZ dirt. Okay, let's try this again. XYZ. I have an extra line there. I do not need an extra line there. They're probably going to ding me on that. I guess I don't need you. XYZ. Foxter dog, Foxter dog. Okay, it's now in twice. What? Why are you in there twice? Okay. Our matching commands needed to get reset. I think. I'm thinking that's what the problem was. The matching commands needed to be reset at some point in time. So if matching commands is empty, if we're in the bell state, so it is empty and all the matching commands LCP are the same. I wonder if I got myself to that with I typed something in, but that should have reset it, right? Hold on, let me try this again. So XYZ, that found them twice. Why do you find that twice? It's odd. Okay, so matching commands. I'm curious now. I kind of want to just print line matching commands. I want to see what those are. And I guess it would also be nice to see what these are. These are just commands. Okay, well, I didn't need to accidentally hit the cube key. I'm running on a it has like heavier I'm on a mechanical keyboard. I have heavier sort of like key switches. I still hit the Q way too often when I'm doing like W and I accidentally hit Q. Okay, so if I do X, Y, X, Y, Z, matching commands, X, Y, Z fox, X, Y, Z dir, X, Y, Z dog. Oh, so that found it multiple times. Interesting. That's the reason for it. I wonder if I actually do have XYZ Fox. No, that doesn't make any sense. Why would you find, do I have that in my path twice? Well, this won't let me do anything here. That's cool. I just get the bell because it can't find those commands. I kind of want to just try to sending it just to see if it's a weird problem on my end. Otherwise, I would probably need to start throwing this into a Docker container so I can control things a little bit better. Okay, so git commit. Oh, I need to not be printing stuff. Where's our print lines? Okay, so here's our print lines, meshing commands. Okay. All right. So I want to. We're just testing to see the does this work? Printing all commands out. Not really a helpful name. Okay, so it didn't get doubled here. It gets doubled for me, which does make me think that somewhere else in my directory I had added those in, and it's finding them all because I do find multiple, which is cool. I could probably filter by name, which would be interesting, but I'm not going to worry about that too much because apparently it's fine here. It's expected cow, dog, fox. We got cow, fox, dog. Oh, yeah, alphabetized. I need to alphabetize, so I have commands of string. I need you to be mutable, so I could commands dot sort. So once I sort that, then it should be happier again. Do I still have that temp? I don't. Switch XYZ dog. That only is aware of there. I don't know what's going on with that. Okay, so let's just test in production. What's wrong with that? Sorting the commands before displaying them. Okay, I think we passed significantly more this time. So we had partial completions are done. Multiple completions worked. So it did what it's supposed to. Auto completion, executable completion, that worked. Auto completion, missing completions. So it received a prompt. It typed XYZ. It matches XYZ. It presses tab and expected the bell to ring, but it didn't. It didn't ring probably because I need to reset the bell state after. I need to reset the bell state after we. Wait a second. Oh, I think that there's nothing here. Length is 0, but the index is 0. Line 95. Oh, okay. So I think we need to first check to see if matching commands is empty. We print the bell, right? We're not even in bell state. We just print a bell. So we print the bell. And then this can be an else if. Now we know matching commands is not empty at this point, so I don't have to test for that. Now I can just check if all matching commands have the same LCP and then continue on from there. So this might work out for us. So printing bell when no matching commands are available. Let's see. Missing completions. Okay, so we passed that. And now we're on to completion with arguments. So it typed ECH, press tab, expecting autocomplete to echo. It did not. It received eck. Well, let me try this again. I did get echo. There's also the echo args. So what did you want? You wanted echo with a space. It wanted echo with a space, but there's more. There's more than just echo, right? Hold on. Yeah, even mine doesn't do that. So, Docker run it. I want this to be auto remove when you're done. Run bash. So if I do, okay, well, there is only echo here. So if there is only one that it can go to, so matching commands is not empty. This is false because there's only one. Clear the line, print the prompt. Oh, but that puts the space in. So is there multiple echoes? Because this should put the current. This should put the space in the current input. That should do that. The problem, of course, being that there's a lot more things than eck. That's my guess. I don't know. I don't know off the top of my head the best way to handle this one next without breaking all the previous tests. So we should be handling that already. Part of this is my brain is a little bit sort of, it's pretty tired right now. We've been going for 4 hours. We've had a few breaks here and there, but that's usually I'm not used to like coding this much this straight. That's why we're doing the warm-ups for building the shell. I think we may have to leave this until tomorrow and then come back to this and sort of figure out what are we going to do? How are we going to make this one work? What exactly are they looking for? I think that they're looking for echo and completion with arguments. I think they're looking for echo and type. Echo and type, I think. I vaguely remember that that's what the tests were. I mean, there is things that start with type. Although I guess for them, they wouldn't have TypeScript server like I do. So yeah, I think next time we're gonna have to start throwing this into a Docker container. And I don't know if I have a Rust Docker container for this version downloaded. So that's gonna be my homework for tomorrow is get that downloaded before we start the stream so we don't have to wait forever for that to download. Then we can play around with it and see if we can get this working. I did go ahead and update my Rust Docker image. So if we need to isolate everything in Docker, should be possible. I'm not sure how helpful that will be. Sort of like looking more on this, looking at the tests. I'm still a little bit unsure that this is sort of how most I guess like bash shells run, although it has been a while since I've just run straight bash. Usually I run ZSH, or at least I did run bash for like 10-15 years or something like that. So it is something that I'm familiar with. I just forget constantly. Now the auto completions, we have different types of auto completions that are happening, and I think that's where it's tripping me up is like when it's certain type of auto completions. I want some things like I think one of the things, and okay, one of the things tripping me up is that this shell auto completes first based on the shell built-ins. So if I want to do a built-in, I and I want to overwrite it with a path, that will never happen. It's interesting. So thinking about that, that means I could fairly easily solve this by adding something, adding a check for the built-ins match first. I think I know a way for us to experiment with this, and that's going to be in utilities. When I get user input and we hit tab, I need to match the commands for, so it would be something similar to this. It would be find matching built-in command or something like that. So pub function. Oh, and don't I have that already? Because I do have this here. I have this matching built-ins. So if I don't do this here, which means I don't need to, let's see what's going on here. Find matching command. Am I even using find matching command? Yeah, there's no references, so I'm not even using this matching command. So we can update this to find matching built-in. Okay, so we have an option, so result option string, so that matching built-ins, built-in command. Okay, so we get the matches the partial. If the matching built-ins length is greater than 1, we get none. Otherwise, if it's equal to 1, we get the first one and we return that. Otherwise, and then here's where I get the other executables, and I want, this is, I think if I just do otherwise none, then I'll be able to come back up here. So find matching built-ins. So when I hit tab, potentially before I even do anything with this, if the matching commands is empty. So I just want, like, man, I need to refactor so much of this and like rewrite a bunch of it, because everything, I feel like everything was much nicer until we had to support 3 different sort of styles of um 3 different styles of autocomplete. So I wonder if I just do if let some, this would be a command, not a command like that, command like this, equals find matching built-in, pass it the current input. We have to do that. Okay, so if we find some of that, I just want to tab autocomplete that. So our current input becomes command, and then we reset everything else. So bell state becomes false. What else do we have up here? So we set the current input, matching commands becomes empty. So matching commands will clear you out. We'll reset the matching commands index. Yeah, definitely a lot we can refactor here. And in bell state, we've already done. Okay, so if I do that, and then I want to say that we can break out of this because we get out of the loop and we're done. Value assigned to in bell state is never read. I guess I can just not do those right now unless they cause a problem. I think that it's read down here, right? Yeah, it's read in bell state, if in bell state. But okay, let's I kind of want to try this. So git commit this is, actually we should probably actually run this first, shouldn't we? Run. Although there is something to be said about waking it up. So I'm going to do that. We're going to git commit. We are matching built-ins before any other commands, and we'll push that up. And then in the meantime, we'll come over here and so we cargo ran you. I want to, echo doesn't do anything. And oh, that was fast. So you still passed on all these things until completion with arguments. So it types ECH. It wants to press tab. And it got nothing. Right. So we need to figure out what's going on with that. Oh, I need to print this out, don't I? So we want to term, clear the line, print the prompt, print the current input. Current input with a space. Yeah, definitely a lot of refactoring I think we can do with this. Okay, let's try this again. So if I run you, I type echo, it tabs to echo. So break is the wrong thing. Oh, I don't want to break. I want to continue because I'm not done with input altogether. Oh, that was okay. So I get nothing in there. I get nothing in here except I do. So if I echo the world, oh, weird. Okay. So that kind of, we're getting closer, but we got a weird thing where when I press tab, I get current input equals the command. Oh, I need to do command plus space, don't I? So we need to format you to be the command plus a space, which in this case means I can just print you out. Oh, much better. Okay, there we go. Yeah, so you couldn't see any of the fun stuff we're going. So here's what's happening right now. If I don't exit, if I cargo run, if I type echo like that and hit tab, nothing's there. But if I type hello again, that, yeah, it's kind of working, but it's disappearing. Now, what I'm trying to do is, okay, so if I get out of the user input, if I continue, that continues the loop because I'm still typing. And so if I tabbed with when I have a matching built in, so echo, for example, I add this to current input. So I reset what current input is. I clear any of the matching commands, so it's an empty vector. I clear the line. I then print the prompt, and I print the current input, and then we continue on. Continue would reset me. Oh, if I continue, I need to. Okay, that's the problem. I need to IO standard out flush. Okay, so if I cargo run U, we type in echo tab hello world, whatever. That works. So let's see if this makes us happy. So handling flushing output when matching built-ins. You should have caught that sooner, but you were focusing on your own code. It's okay. It obviously is going to suck for the anybody on YouTube, so sorry about that. But hopefully it wasn't too long. I don't actually know when it started. Hey, okay, and I got everything to pass. So we have this sort of huge code smell in here. The entire auto completion system is going to need to be rehauled now. But we're done with auto completion. Like the entire section for auto completion is done. So I think now is the time to refactor that, especially with pipelines coming in. And now that we're doing this entire thing with term and the get user input, it does make me feel that we should be able to parse through the input as we go. And so I think this should probably be a new file, which will make it easier to sort of add things in too. Oh, the time in the corner said 7:53. Oh no. So it froze well before the stream. But I hadn't even started the stream yet. Okay, so next week when I start the stream, one of my pre-checks will be check to see if it's working. Although I guess the problem I had was I did switch it to the starting soon, so I wouldn't be able to see that. So I don't know. I guess when I just start up right away, it's like, ooh, is that still running? Should I reset it or not? We haven't had that many problems with it recently. I do remember when I first set this up, we had this issue all the time. So that's a good sign. Okay. How do I want to do this? I'm thinking I have this input parser. We're going to get rid of the input parser. We're going to get rid of get user input and some of those other helper functions in here. And everything is going to go into, I'm just going to get user input. Okay, so we're going to have a pub function get user input. We will probably take in a term. The terminal will be a mutable reference to a term. We're going to return a result. And this can be, right now I'm going to have nothing in there, but we're definitely going to have some kind of user input, I think. We're going to have some kind of struct for this. So we can create that now. We can say, I guess to make this happy, we'll just do that. We know we're going to have like a command. We should probably redo the, yeah, everything is going to go into here, isn't it? Let's do this one. So we have this built-in commands should probably also change, which would allow us to store things separately. I wonder if, okay, so that's just the command, built-in command. This will be a user input. So pub struct user input. That's what we're going to put in here. So, okay, so we'll return user input. What do we care about here? We'll probably be wanting to, well, if I'm doing that, do I even need a function like this? Because I could just do get. So if I do something like this, function get, you're going to take in the term, which I don't need to store, so we'll just take this in when we need to. Okay, so I might want to have like a new function to create new and pass things in at the end, because get is going to get. Although I suppose I can break everything out into their own little functions and then call them. I'm not exactly sure how that's going to look. So right now, input is going to be equal to self like that, and then let's return okay user input. I'm breaking this out into two different little pieces just because it's going to be a little bit easier for us to work with. As soon as I switch over to this, everything breaks. Like absolutely everything, which is going to be fun. Okay, so what's the very first thing that I want to do here? We now I have this loop. This is our sort of like the REPL loop where we're looping through. I print the prompt out, but I kind of only need to print the prompt when I get the user input, right? And so because of that, I probably shouldn't need to print you here. I would need to print the prompt that's a side effect of getting the user input. So if I do that, it also does make me wonder if I should have like a new and then get, I just have one user input that I constantly call over and over again instead of recreating this over. Well, maybe. Actually don't know if I want to do that. Maybe it probably is best to like recreate the struct every single time. But storing what the prompt is could be helpful. So if I have like the prompt, which we can call PS1 because we know what that is. We can make this a static stir, which in that case, making this be a one-time thing that we call over and over again might be what we do. Let's try it that way and then see if we need to change it. We're sort of one of the problems that we're running into right now is like it's such a big refactor that I still don't know what the proper direction the refactor is in. I just know that it needs to be refactored. So I'm just going to go in the direction of just doing it and then sort of getting more information as we go. And if that means we have to rewrite this, so be it. So if we have new here, I want to take in a PS1 at this time, which is going to be that static stir. And we're just going to return self. There's no chance that this can error. So we can return self PS1. So I'm not even going to put the get in there yet. So, so our user input. Okay. And then our prompt is going to be just a $sign. Okay, so now we have user input. When I get the user input, so this is I did all this thing is like part of get command. But if we really think about it, I want to get the user input. It's like this back and forth thing, right? I get the user input. I figure out what the command is supposed to be. I run the command. So let's write that out. So we get user input. Part of that is printing a prompt so they know that it's their turn to put something in. Part of getting user input would be handling any autocompletes. Then we figure out, so once we got the user input, we figure out, so if command is built in, why did tab bring me down there? Oh, that's weird. If the command is built in, run it. So maybe I'll just do it here. So if the command is built in, run it. If the command is not built in, check if we can find an executable. Well, and so like that's still part of get user input, isn't it? Because get user input, when we do autocomplete, that will check to see if there's executables or anything else. I suppose you can still run whatever it is without a tab autocomplete. And if we can't, so if it's not a built-in, and if we can't find an executable because we may not have auto-completed it. So if we can't find an executable, print error. If command is executable, run it. And then I think we start over again, don't we? So I guess the output of user input is this command. I just want user input to be broken up into different parts. Like this is the command this is the command string. This is like any redirects, anything else like that. So that's what we need to know in order to get the command. Right now I'm doing all of the parsing through here, but we can sort of now that we're getting one character at a time, we might as well parse it here. So if I just copy out this entire thing, so nothing will work anymore. And that's fine. We still have standard out and standard error, so we'll have to deal with that. Okay, so get user input. So pub function, we want to get input. Really, we want to get a line, right? So we call this like a read line because we're kind of implementing that. We take a reference to self, but we take a reference to self and the term. That being said, we don't need the term for anything else up here. So I could just get rid of term. So we don't need the term here. We're probably going to return a result. And then let's say I don't want this to be a different I want this to be a different struct then. So if I have like a pub struct, like a user input line, that's what I put in here. Throw a to-do on here so we won't get any errors. Okay, so you're happy. Okay, so first things first, we get the user input line. So this is going to be a user input line, user input, read line. Okay, we don't have to pass anything else in. So we have that. Now, what do we need inside of this? We need all of the user input that's come in, don't we? So we're going to first print the prompt, and I guess like if I currently just return, okay, user input line like that. I'm not going to worry too much about that. I'm probably going to have to change that out to maybe either a builder for user input line or something else as we go through and collect things. But until then, I'm going to do this just so that it compiles. I want to print the prompt right here. And if I want to print the prompt, that's two things. So pub function, you don't need to be public, do you? You can just be an internal. So print prompt, we have self, we don't return anything. That's not true. I do have to return a result like that. So we're going to print self.ps1, and then we need to get an IO standard in so that way I can flush the terminal. Now, I wonder if I could use this term to print out, and that might be a better way of doing this. So what if I do something like this? Term, it's self-term. Self-term, okay, so I don't want to write a line. Just write a buffer. I'm surprised there's no write. Yeah, no, don't, let's see, write all. Okay, so this writes a buffer into this writer, returning how many bytes were written. The function will attempt to write the entire contents of buffer, but the entire write might not exceed. Yeah, I'm a little bit surprised that there's no like write character, because I can do write. That's pretty easily. I'm wondering if term has a write character. So I see a write, and if I just do write, yeah, okay. So I see a write. I don't see a print. The vectored thing isn't too bad. I can write that in there and it'll be fine. So if I do write, so it'd be a buffer, binary. I think it's converted into a buffer, right? And then I want, I need to format this. So format, but I can't do that anyways. Use the write macro. Does the write macro, I don't think the write macro lets me write to this one, right? And this looks like a re-export because it doesn't look like there's anything terminal based on it. So like what's the writer that I could write to it? It implements the write trait, therefore the macro works. Yeah, I'm just curious, like because for this one I need the buffer, don't I? writes it into a buffer. So I need to know what this is that I'm writing. Like, don't I need like term, self term something? Because that writes it. Is there a buffer? Just pass the term? Okay, let's try it. So if I pass the term itself, and then the rest here, I could then do self dot ps1. Well, term is stored in here, so it's gonna have to be self term. Expected an item. Where is this? This is in the main library. Oh, I think okay, that's better. We're not matching these commands yet, so we'll have to comment you out right now. Expected right curly. Was it this one? Yes. Okay. Unreachable destination because, well, things. Needs to be mutable though. Okay. Mutable reference to self. Mutable reference to you. Okay, that. Okay, so read line. We first self dot. Let's say you need to be mutable. Print prompt. Okay. Unused results. Okay. Let's see. Are you gonna be happy with this? I have just a bunch of warnings, but no errors. And I can probably get away with just moving to the right, and we'll just do this here. So cargo run. Well, that prints forever because I am in a line, but I am printing the prompts. That's great. So that does work. Yay. Okay. So if I do that, I'm kind of surprised I don't need a flush. I wonder if it's auto flushing after it reaches a certain amount. And so therefore I will need to flush once I go for getting the current input. So then the next thing is I want to self dot term. I want to read the key. So we're gonna let get key, and I could just match this straight off. So let's just match you. I wanna get to where it doesn't cause all sorts of issues. Let's just say, hey, for everything that we get here, I want to do a no operation, and so we don't care about you. Read key is a method. Okay, so we want to try not being mute. So if I take you away, yeah, cannot borrow a self term as mutable. So this does need to be mutable. You need to be mutable. So yeah, you were right. You were right originally. It does need to be mutable. Okay, so now I'm gonna get a key. Sorry, now it's gonna wait here for me to type stuff in. Interesting. Every time I do a key, it just types another $sign. But that's a different issue altogether. Oh, you're right. I've missed that. Okay, that's running. Okay, cool. So we have our prompt showing up like this. That's fine. Now, when I start typing, I want to start putting things into a like what the user input line is. So we want the partial thing is. Now we can store that in here in just a let, and I can store that in the user input, but this resets every single time we go through, which makes me think this should just be set up here. So if I do a let mute, this is gonna be the partial or just like current user input. So current input. Now, is this true? Should we do this like this? We're gonna get a word. We can possibly tab autocomplete during that, which means we need to know what part of the command we're in, because we can only tab autocomplete during some of them, or different behavior for tab happens at different times. So what I might want to do is have like an enum, because we're in one of different things. So if I have a pub, this might not even need to be public. So if I have an enum, this would be so current input. We begin with, we're in the command part of it. Like what is the command that we're trying to run? And then this would be a string that we're appending to. So in read line, we're going to have let mute our current input is equal to current input. It's a command. I can impl this. Yeah, let's impl this. So when I create a new one, I just want a self command with a string new. I'm mainly doing that to keep this simple up here. So current input new. Okay, so we initialize a new current input. We print the prompt. We then read a key. Now this is, we're gonna have to start an infinite loop here and then read the key inside of here. And so if this is a character, what did you give me? You gave me a key. So if you're a key, let's do console key. Okay, if you're a console key character, we have a letter coming in. I want to push this into the current input. But of course, what we're doing depends. If we're in the command, it gets pushed into the command. So this basically becomes our state, right? I'm already thinking about like whether or not this is a good idea, because an enum is like only one of the things, right? Because what are the other things that we can be in? In the command, after that we can be in arguments. So we can be in arguments, or we can be in redirect. But there's other things we can do too, like redirect standard out, redirect standard in, things like that. So if we want, do I want to actually store this inside of the enum, or should we store like whatever this is outside of it? Like we're just keeping track of the state. Then this might be current input state or readline state or something like that. Maybe readline state. That might be better. If it's readline state, then I check here. Okay, so if your character, I guess regardless right now, we're pushing this up. Oh, and an ad break is starting any second, which will give me a chance to go and open up some of the windows here. So I think we'll go ahead and take that ad break. It auto what is it called? It auto did snoozed twice for us automatically. Oh, I hate you, Clippy. I didn't update Rust before committing, so a lint broke your CI. Oh no. I should probably set up Clippy in the in Helix here for us. I don't remember if I have Clippy on. I don't think I do. That would be interesting to do though. I bet a lot of the stuff that I have would break. So maybe for the next project, we'll set up Clippy and make sure that it's running. All right, and the ad break officially started. I'm gonna get up, stretch a little bit, and go open up some windows, and then I will be right back. It just means you need to integrate Git hooks into the tool you're developing sooner rather than later. I guess it's better to integrate those sooner, because then if they break or you just need to change anything more because of them, that's probably a good thing then. Okay, I think I know what we're gonna do. I think we're gonna have a partial, because there's a bunch of things where it's like based upon the next character, or the next two characters, or something like that, and we don't know what that's gonna be until we get it. But if we know what the state we're in, then we're good to go. All right, let's do this. I'm gonna update this to current input state. We're not gonna need a new for this. Let's see. We're gonna begin with command, but then there's arguments and there's redirect. Regardless of what we're sort of going for here, we're gonna have, let's see. So let we need to change this. So probably mutable is right. So our state is going to be a current input state, and we begin with a command. Let mute. So we're going to also have like a partial of like whatever is partially coming in. That is going to be a string new. I could do a vector for this too, and we can change this around. We've had some good luck with strings in the past for this, so I don't really know which one is best for this. Both of them take up unknown amount of memory, so I'm not really that worried about it because they're both on a heap. Okay, so we print the prompt. Here, if we're getting a character, does it matter what the state is. I'm not sure it does. I want to say that we just throw this into the partial. Is that true? It's not always true, because if we have like a quote, if we have a quote that we're inside, then we don't put that in. But if we are in quotes, we do. So yeah, this is gonna be sort of like our uh, parsing too. So I wonder if we should just do this as normal. Like we're in normal here. Normal. Okay, so now I could also break this out into different functions just to make it smaller. That I kind of feel like I should, like just add key to state, but I'm not 100% sure yet. So if our state is current input state normal, oh, there goes my dog barking again. Well, my parents' dog. I put this in the wrong one here. You go there, you do nothing. Okay, so if we're in normal state, then it's going to depend on what kind of thing this is, right? Because if it's a quote, then that's an entire we go into quote mode and we deal with that because we can quote commands too. So do we have two states then, don't we? We have like what thing that we're collecting, we're getting the command, right? So we have two different types of states. We have the input state, and then we have what is each part of a command of a read line state? We have like what thing we're collecting, which is commands, arguments, redirects. And then we have the I guess just character state, which is like quotes, tab characters, things like that. So this might be like a read line state too. So we begin by getting so you're a input state, you're a read line state. Okay, so we're in normal mode. Ooh, input state. I can change this. This is actually a parse state, isn't it? This is a parse state. So we're in normal mode for parse state. Okay, so we're in the read line state, we're in the parse state, and then we have our partial, which is kind of a buffer, just sort of a collector for what we have currently, which we might pop things off of, add things onto before we go to like the final to set it into whatever the full thing is, because we know we're going to need the command, the arguments, and everything else. Okay, so we print the prompt, we get a single key. Isn't that covered? Oh, that's weird. I feel like I screwed this up. Yeah, I need to close you one more time. That's what it is. Okay, so if we're collecting the command, we still need to worry about quotes, don't we? So if we're in command, it makes me wonder whether or not I should break this out from readline to like be get command. I'm not sure. I feel like this is going to get pretty pretty crazy here. This is getting each character. Okay, so what if I just get the key code that's coming in? So okay, so if I get the key code, and then we're going to match on what readline state that we're in. So if we're in the command state, I might want to just throw this off into another function down here to break this up. It's still doing like a relatively normal thing, but this should then return a command. So instead of a partial here, if I just say I want a command, we have another function here, which is going to be a function get command, or just readline command, because it's part of that. In this case, I probably don't even need to store the parse state up here. It's going to be inside of each of these. And then I'm going to return a string, which is going to be the command once I have that. Now, we loop through here until we have the command that we want to get. Okay, so where do we still need a loop up here? We print the prompt. I might not want, Oh, let's see. I think we're going to need the loop here still. But if I'm doing this up here, the loop's happening here. We're calling this command over and over and over again, which means I am not returning. So command is going to have to be mutable. We have a new string. We take u in here. This is the command, which is a mutable reference to a string. I can't do a stir. I think I have to be that. I don't return anything. I'm just going to update our command. I don't think we're going to have parse state up here. We do have to have a readline state. So we print the prompt, we start the loop, we get a key code, we match on a readline state, and then we also have to have our key code, which is going to be a key. Okay, so we get the readline command, we pass in a mutable reference to the command, and we pass in the key code. And you don't return, at this point, you don't return a result, but we might in the future. And we don't currently have any way of returning from this, do we? Because when we're finished, we break out of it. And how do we know we break out of this? We break out of it when the key code is return. So I could just do if matches key code. Okay, so if it's enter, I want to break. And then we go out here and we exit out. Yeah. You'll need to be mutable eventually. I know. A whole bunch of warnings. We have so many warnings. Okay, so readline command. Okay, so we get this. Our command is our partial, and so we're just updating this as we go along. We get our key code, and so how naively do I want to do this? Less naively than I did initially. So we know we're gonna have to handle quotes and other stuff like that. So I just want to check to see if we're in partial or not. Ooh, it took even longer before you came in. Let's ban you. All right. If you're normal, we just put in the command and that's it. So we're going to match. Okay. We're going to have a parse state up here and then pass this in, aren't we? Because otherwise we're going to lose it every single time. So let mute parse state. I probably want to change the parse state here. So this probably should be a mutable reference to parse state. Okay, so we're going to match on a parse state. We're going to have parse state. Okay, so if we're in a normal parse state, I want to get whatever this key code is. Like, I want to get the normal quote. So, I think it's some. What can I get out of this? Key code. Yeah, I can if let. What options do I have in here? Unknown arrows, enter escape backspace. Okay, so nothing special. The tab is here, so we might need to, we're gonna have to deal with that at some point in time. So I might want to match this. But the only thing I care about this is the character right now. If we're in normal mode, and I guess it's not always gonna be a letter because it could be a quote. So this is, we have our character. We're going to throw our character as long as we're not a quote. Okay, so we need to check to see if we are, as long as it's not, okay, so if it's, do we have to match? Do we have to match this and go match? That might be easiest here, right? Because if I match on the character, so if it's a quote that we enter into single quote, and we don't push anything in. So our parse state becomes parse state single quote mode. Then our next one is double quote. And so we're in normal mode, right? Yeah, we're in normal mode. So you have double quote. So in that case, our parse state becomes double quote. And if we're in normal key characters and we get a backslash key, then we don't print that out and we print out what the next thing is. This would be, we're in now escape. So parse state, escape. But everything else whatever it is, we push into the command. So command, we push the character. Okay. You're not liking the idea that this is key character. So if I do no operation here, you should be a little bit happier. And then parse state, we have all these to dos with like, if depending upon what kind of parse state we're in. Okay, so I think this is normal characters coming in here. Right now, when I'm typing, nothing happens because I think that I'm not allowed to see what this is until I print it out. So I'm updating the command, and then the final thing here is at the end of the loop. So we update our command. I want to write out what I need to write out what the new like what the full line is essentially, or I need to append the character to the terminal. So like just write this out. That's another like question is like, ooh, should I do that or not? And a point of like whether or not this is even a good idea to put this down here, or if we should go back to just putting it all in here. Because part of me thinks like, oh well, based upon this command of like, I just want the entire line, and all I need to know is, have we hit that first space yet? Because if we've hit the first space, then we're in a command. Sorry, if we have not hit the first space yet, we're in a command, which is the read line state. I can know that we're in a command or not. But until then, everything goes in, which is part of command, and then I just print that out. This does feel like a pre-optimization that I don't actually know is going to help with us. And I don't actually think I want this. I think I want to just read the key codes. I think I just want to match on the key code and then do the things based on this, right? So if we're in a character, then this, we put things into our command and we print them out to the screen. Do I need to store this? I think I do. Because if I look at the line right now, it has the prompt on it, and that's going to screw me up. I'm going to guess I could filter that out when I need to tab, but I only need the command partial in here up until we're done with the command. Then I don't need that anymore because we're not doing tab autocomplete for arguments or anything else like that because we're not supporting that with this shell. So I guess for just this, if I just do it right and we flush you, right, the enter breaks. All this means right now is that when I run this, we can see what we're typing. So that works. I can't backspace, so let's handle backspace really quickly. Backspace is the reason why I need to throw this into command, don't I? So if we have our command, I kind of want to rename this to be just the line, right? It's the input line. So input line, push the character on, backspace, we remove it. So input line, pop you off. Okay, self term. I don't want to clear last lines, not clear line. Clear the last n characters of the current line. So clear characters 1, and then self.term flash. So I can type things and I can go back. And I should, because we're piping and we're pushing, we should have input line be up to date. Oh, and that's the reason why I have to do my, that's the reason why I'm going to need, it's going to be rough if I do this having to parse through live because I have to now keep track of like what's displayed here and what's here, right? If I don't even have input line at all, so I don't need to keep track of you, and so I'm just adding you in or not, that still works. When I get the line, I'm gonna have to pop off the prompt, which is fine. That's pretty easy to do, especially since we have the prompt. I can just remove the prompt from it, and then we pass that through to the, I guess like the get command that we have right now kind of works, doesn't it? I might want to rewrite some of that because I think some of it is a little bit over the top, overcomplicated. But I guess right now all we're trying to do is just work on this, and if we tab autocomplete, it auto completes. The problem being that we're auto-completing in 3 different types of things because we have autocomplete for externals, we have autocomplete for built-ins, and we have autocomplete for um, the bash style where we press tab twice, which sucks, but we can deal with it. Okay. Um, how do I do that here? Well, if I'm fleshing twice here, I don't need to do that, right? I can just flush at the end of the loop each time, and we should still have the exact same result. That still works. Okay, that's great. We're pretty much just at the point where if I press tab and I have a character, so I just need to know if we can tab autocomplete. That's a single thing. Okay, I'm pretty sure we're not going to use this readline command anymore. So I can get rid of you. We don't have you. If I have just a single flag that I'm looking for, I don't think I need an enum for that. And so that would just be a let mute um, if we're in the command still, right? So in command, and that becomes true. So we're still in command. How do we exit the command? If we hit a space, and a space is a character. So we'll write out whatever this is here, but then also if our character is equal to a space, then in command becomes false. And then based upon everything out after that, when we hit tab, we're gonna have to check that and then deal with that. Okay, so I think if I just do this, I should be able to do echo, and actually I should be able to do echo with arguments, the built-ins with arguments. I think those would work just fine. Heck, maybe even the other ones too, because I think the command basically just tab autocomplete won't work. And I think that's fine. So if I take you and we change you to we're just returning a string, when we hit return, when we hit enter, it's not that I break. I'm not going to have that. We're going to get the current line. So our user import is going to be self.term. Can I get what's currently there? Read one line of input. This does not include the trailing new line. If the terminal is not user attended, okay, it is user attended. I'm curious about this. So if I get you, let's just print what you have. And then also we return the user input. We return okay, the user input. Okay, so we're getting the user input, and then nothing else happens right now, and that's fine. So if I type echo hello world, get user input line 33. I put this under escape. Oh, how silly am I? Okay, put you there. Escape, we don't need a handle. Yeah, there is no escape. Yeah, there's no escape. Basically, escape right now just crashes, but this should probably be a no operation. Control C, like we'll deal with this shortly. Let's try this again though. So echo hello world. User input is nothing. I was really hoping. Okay, so that tells me I do have to keep track of what we're putting in here. So we have to add that in. So let mute. So we have user input. This becomes a string. So just a new string because we're popping off things and adding them in, and this is fine. So I don't do that. This becomes user input like that, and return okay user input. Backspace. We have to both clear the terminal characters and then also user input pop off, and then when we write the new character, and then also user input push character. Okay, so echo hello world. So user input is echo hello world. Perfect. All right. I probably want to do a new line here, but I might want to do a new line elsewhere. I basically just get the user input, we return that, We get to the main library. Okay, so we've read the line. I have to decide when I want to put the actual return. I think it would make sense to on enter put the return in here. So I'm just going to print line. If we're doing everything else here, let's just continue on with self. Self term. We write line. Okay, we have this string. I then need to get the command from this string, which means we need standard error, standard. Let's see. Yeah, I don't think this needs to be anything crazy like that. Okay. You need a terminal, don't you? Why do you need a terminal? I guess for right now, I'll create the term, but I don't think we should have to have it here. Okay, so no errors. We get the command, and then we're going to run the command and do standard out and standard error. Okay, so now I should be able to do things like echo hello world. Oh, that doesn't work. What happened here? Oh, user input line. Because get command is getting the user input from here, and we're not doing that anymore. So I now want to get the user input from you. So user input is a stir maybe that we get. Oh, you need that to be a string? Fine. You can take ownership of it. Fine, whatever. Oh, I'm not even using the command? Okay, I'm using term? Great. Then I don't need that. Okay, so we don't need the terminal, and we replace you with user input line. We don't need you, and we don't need you. Okay, that's not true. We do need you. I may not need to create this as a struct here. Okay, let's try this again. Echo hello world gives me echo hello world. Echo quote hello world. Okay, so that seems to still be working now. So if I type echo, if I pwd, that's a built-in too. If I cd down, oh, cd is a built-in as well. But if I ls, that works. Oh, tab autocomplete for that part doesn't work either, but we're not going to handle, I think, tab autocomplete in arguments. So I think we're fine. Okay. Yeah, you don't need to be mutable. We don't need term there. We can actually start getting, okay, we can't really get rid of warnings there. So with the main part of the shell working again, that's great, but the biggest part is the autocomplete, right? So when we hit tab, if we're in the command still, if we're not in the command, then we just exit out, right? Because, or we just continue because tab shouldn't do anything at that point. At least our shell isn't handling that. So if not in command, we can just continue. But if we are in the command still, then we need to figure out autocomplete. And so this was like the entire big sort of like mess that we're trying to fix. Okay, so there's the 3 different types of autocompletes. We can take a look at them at CodeCrafters here. We have built-in completion is the first one. And so we should check for that. And if it works, we don't even try the other type of autocompletion. And this is just checking anything against built-in, which we have. And it makes me wonder, can I do like a, we attempt to autocomplete. So if I autocomplete built-in, don't think I need a result. That we might need to as part of that. But it's probably going to be an option and a string. We've taken a reference to self. We're going to have to take in the command so far, which is a stir. And I think that's it. We then want to built-in command matches gives us a vector. Okay, so matches, we give it a command so that matching built-ins. How did I just put a space in there? Okay, so now you're just yelling at us that we're not doing this. I just want to get the first from here. No, I want to check to see if there's only one, then it auto completes. Otherwise, it doesn't. So this is autocomplete one built-in. So if matching built-ins length is exactly equal to 1, then we're going to return matching built-ins, get the first. Otherwise, turn none. We do have to clone you. Okay, so now in tab, we get to this point, and so the first type of autocomplete is autocomplete one built-in. So if let sum, this is completed command equals self autocomplete one built-in with the, what do we call it? Is it user input up here? User input. Okay, so if that gives us that, then what do we want to do? We want to then set user input to this. So I feel like we're going to lose all of the quotes in it, which is wild, but I don't think their tests actually care about that. So user input equals the completed command. Yeah, so I think actually we have a bug in both like the previous iteration of this and this one, which is we lose quotes, but I don't think the tests actually test for that. So it's fine. Everything's fine. Okay, so we do that. We have to add in a space too. So this becomes actually a format where it's the completed command with a space. We then also can in command, we're no longer in a command because we've auto given it a space. And then we continue on, which means we'll just continue like this. Okay, so if I cargo run this, I can, tab autocomplete doesn't work. What's our problem? I print line, let's print line what our completed command is. So tab auto completing user input. Oh, we never get here. Okay, so I begin in command, right? So that continues because we're true and this is if false. So it's true, we continue on. That should print out, shouldn't it? But if you're not printing out, I kind of want to know what the heck this is. Print line just in command is in command. Well, that time I got it. Did I just fail to save it last time? Yeah, autocomplete. Okay, I failed to save it last time. So we have echo auto-completing ec with no white space or other weird things going on in there. So if I autocomplete this, built-in match-ins, that's okay. It found a single one of echo. So if matching built-ins length is equal to 1, I want to return matching built-ins first, clones. That should return this. Oh, I need to print it out, don't I? I forgot to do that. So we replace user input, and this is the reason why I'm going to need, okay, so in command false, I need to replace the line. I need to rewrite line self, and then like what the user input is so far. You're going to be a result. I don't care about you because you're just affecting external state. All right, so we want to self term, we clear the line, we then self print the prompt, we then we then write, okay, self terminal, and we write user input. What am I doing? Change you to that and that. Okay, we rewrite the line out, self dot rewrite line, pass it in a reference to user input. Okay, echo like that. All right, so echo hello world. If I do type, echo even exit works and exits out. Okay, so tab autocomplete for one built-ins are working. So let's do tab auto completes refactored for single built-ins, which is just in time for our break. Fortunately, it's a very early development as actual users would now be banging their heads against the desk. That sort of like pre-time where actual users don't yet exist, unless I guess we count ourselves as actual users, right? Yeah, having that not be a thing on our shoulders when you're first setting something up is so nice. Because later on, when you're doing stuff, you're like, well, is this gonna like break things for like 100 people, 1,000 people, 10,000 people? That can get a little bit more nerve wracking. I'm kind of curious. No, because if I push this, it's not gonna work, right? Because it tests against like the most recent first. So I can't really properly test this. Okay, ad break is on. The next thing we're going to work on is tab autocomplete for the completion with arguments, which I think is actually already going to work with this because it adds the space in. Because I think that's the only thing it cares about. So I think we've covered that too. Missing completions. Handling invalid completions. When the user types a command that doesn't match any known built-in and presses tab, your shell should leave the input unchanged. Don't modify what the user types. Ring a bell. Okay, so then it's the bell thing. So this is where we need to start tracking state. I think the thing for me that is confusing is missing completions versus multiple completions here. Wait, no, not that. Missing completions. That's just a bell, right? Yeah, so just a bell. Executable completions. Start typing the next one with every tab, but only after the bell, right? Your shell should complete it to the full executable name. Okay. Hey, welcome back, everybody. And this is also for full executables. So, okay, so we've got built-in completion. We've got completion with arguments, which is also built-in completion. Missing completions is now ring a bell if there is no, and I think this is going to be if there's no built-ins and there's no external commands to complete. I want to say that. So if we get to here, we now need to handle missing completions. Check if there are completions, and if they're not, ring the bell. The previous, let's see, the previous input, what did we do? So we do tab. So we find the matching built-in, which is what we did. If the matching command is empty, okay, so if we have matching commands, okay, so there's no external, so I think that's what it is. There's no matching commands, and there's no possible executables. I think that's how this works. Basically, if no possible matching built-ins or executables, ring the bell. That's what we want next. Which means I probably should, I wonder if we should get both. So find executable files and then find the built-ins. Well, I guess okay, so if I find the built-in, so if we check function, we'll check the first one first, which is like if they're possible, like this is not going to be very efficient because I'm going to be doing these like searches across the system multiple times. But I think that this is going to be the best way to pass the tests. It's not something I would do in a shell that I'm writing for real. I'm really doing this to optimize for passing a test and making it readable code passing a test. I want to check to see if there are is no matching executed. Like that's really what I want to do. I want to say like, are there any matching executables, or I guess I wonder if I could just do possible commands. So get possible commands. Self, we get the user input. We might need a result from this. We might not. We'll do a vec probably of strings. And so we'll start with the matching commands again. So let matching built-ins, built-in command matches. We pass it in user input. So do I need this? I don't think I do. And then if this is greater than 1, I can pass this in there. But if it's empty, we go on to the next thing. So if matching built-ins length, if that's greater than 0, really, we're going to do an early return of the matching built-ins. Otherwise, for right now, I'll just return an empty vector, but we're going to be replacing that with the find executables command. Okay, so tab, we get to here, and now we're going to say possible commands, self dot get possible commands, pass in user input. We get that if the possible commands is empty, we want to ring the bell. So function print bell. I'm gonna actually just have a print bell here. We're gonna have a self. I am gonna have to return a result, just the way that this works. We're gonna do self.term. Actually, we can just write, right? Unless there's like some kind of bell character. Okay, I don't think they have a bell. So we're gonna write. Is it a shell yet? Sure, absolutely. No problem, no problems. I put this into utilities, didn't I? Okay, so if I write that, and then I think I have to flush it. So self.term flush, and we okay you. Okay, so print bell now happens up here. So if you're empty, self.print bell. Okay, so if we try this again, does it have the REPL yet? I mean, kind of. So I can echo hello world. I can do that. So if I do, let's see, what's something that doesn't exist? If I do that, I got the bell. Okay, so we get the bell because there's no possible autocompletes there. It's excellent. Because if I try to autocomplete something that does exist, it will actually autocomplete that. So that's great. So I think that's working. So we're still refactoring. We are printing bell when no auto completions are possible. Okay, so that's missing completions. So next up is executable completion, and then we have multiple completions. So an executable completion. Okay, so if it finds the custom executable in the path, pressing tab completes the custom executable with a trailing space. Oh, then execute your program like that. Okay, so I think that's fine. I wonder, this is where doing things in like a Docker container where I can set the, actually, you know what? We can make things a little bit easier on us by setting the shell. So if I in here, we just say our export path equals let's do home bin, probably user local bin too. Although I don't actually know for certain that I really need to. I might ruin this this terminal, but that's fine. Who cares? Yeah, it so wants this. But if I now run cargo run, can I even cargo run? I may not be able to cargo run now because I don't think I have cargo. Yeah. Okay. Can I even source? No. Let's see. Which Perl? That's user bin. Which ls? Yeah. I can get away without LLs, right? In this shell. That's the user local bin, and and then cargo is which cargo? Actually, I'm kind of curious. That's interesting. Okay, so copied from CodeCrafters run.sh. Edit this to change how your program runs locally. Interesting. Okay. That's fine. So let's see. It builds it, but it CDs to the correct directory. It sets, yeah, exit early if there's any errors. It builds, and then it executes CodeCrafter shell. I think whatever, I forget. Oh, just the first. Oh, interesting. The first thing. I don't remember what at does. I mean, I can echo that out in there, but I don't think that's a problem. If I do something like path, um, user local, I have so much crap in my path. I wonder if I can. Let's just echo. Let's put this into my path, my pat, whatever. Okay, so don't need NVM stuff. Um, okay, so my bin is probably fine. User local bin is fine. More NVM crap. Don't need that. Uh, I have this in twice apparently. That's not useful. I should probably update my path and just make sure it's working properly. Because here's user local bin again. Cool. And user local bin a third time. Wonderful. I don't need that. User bin might be okay. Slash bin, user sbin, sbin. I don't even know if those exist on this system. Okay, I don't need any of these Apple things. Don't need you. Don't need you. Don't need the Podman thing. I do need. Okay, so cargo bin. Apparently ghosty stuff is in here. Homebrew bin, fine. Rust up tool chains, okay. I'll take the rust stuff. I have homebrew in here twice. That's cool. Huh, I have rust up in here twice too. All right, so that's significantly better. So if I let's actually, okay, hold on. Let's export path equals just to that. So if I can I source, I think that works, right? So echo, yeah, significantly smaller now. Okay, perfect. So if I so we'll run this export path that, oh, now you hate that? Huh. Thought that would have worked. Oh, why did I lose my path? Source. I lost that. Okay, fine. Try this again. Um, did I like? No, I have that still. Export path. Do I just want to? Oh, because probably can't. No, I should be able to source that, right? I should be able to source my path. Echo path. That's fine. So if I cargo run now, this is all great. Okay, so I now want this to ring the bell for other commands. So if I do XYZ, I get a ding. That's fine. If we look down here, I have XYZ, dir, dog, and fox. So I actually do want that to not ding because we have multiple commands in here. So get possible commands. Okay, so this is just the matching. If there's matching built-ins, we return those. If there's not matching built-ins, I need to get our path. So our path. Okay, so we now have our path. I can external executables. I want to find executable files, the name of what I'm searching for, and if it's a partial match. So in this case, I want to find the user input. The paths are my path and then true because it's a partial match. I do have this as a dir entry. Okay, so if you're I guess I can into iterator this and we can map this straight to a bunch of strings. So we have dir entries. I want to convert this to strings so that we're going to have our dir entry. You get the file name. I then want to turn it into a stir. I can only do try for each, so I have to unwrap you. I can do unwrap or default. Oh, I can map. I can filter map. Filter map. That works. So stir is an option. So that returns a none if nothing. And then I want to just take ownership of it. And then we're going to collect this into a vec of strings. Okay, let's see what we got here. What are you yelling about? Okay, you need to now return a result. Okay, you're okay there. You're gonna be okay. So actually, you're gonna be okay. External executables. Oh yeah. So you need to be some. Okay. We have an error here because if possible commands is empty. Question mark u. Oh. Possible commands. Yes. Question mark here. There we go. Okay. We have a couple warnings. Don't care about you. And we don't have print prompt anymore. Okay, we have no warnings, no errors, and this might work. Basically, I think it just means if I type XYZ and tab, I don't get the bell because we're not in bell state. Oh, sorry, because it did find auto completions. Now it doesn't know what those are, but that's fine. Okay, so, but if I do this, that bells because there is no match. So I think that this I think that this still works with missing completions and with executable completion. If there is okay, so if there's only one possible executable to run here, it should tab and then add the space in, I think. Okay, so if there's only one, okay, so if it's empty, we print the bell, and we're gonna have to go and let's see. We're also going to continue at this point. So we're continuing on this sort of level and not indenting in too much. If we have only one, so if possible commands, so length is exactly equal to 1, then we want to do this thing. So our user input is now going to be equal to, we're going to do the same thing here. So format, this is our possible, oh, I have to do this way. So possible commands of 0. So extract that out. We reset command. So in command, we're no longer in command again. Self, rewrite line. And then we continue. Okay, so that's only if there's one of these. So if I run, there's multiple bashes, XYZ, there's still Fox. Okay, and then that auto completes. Okay, great. I'm just gonna remove that my pat before I accidentally do something with it. All right, so git commit. Okay, what did we do here? We are auto completing when we have only one possible external command, and then we have multiple completions. So in this stage, you'll implement tab completion for multiple executables that share a common prefix. Because like partial completions, which we just did. That's the thing is like I think what gets me there is that these also share a common prefix, but they have different LCPs. So in order for me to know, I have to now get the rest of the I have to get the rest of these. I have to get the rest of the possible commands, and we have to add in the LCP to it. Or rather, we just need to know if all of them share a common prefix, what they call. Is the word prefix, am I just not understanding what that means? I think it's like the prefix is, if I type in XYZ, the prefix is XYZ. It's not foo. But so I need to know if essentially the length of all of the possible commands are the same. If the length of all the possible commands are the same, then we have multiple potential matches, and we do this thing. So is I feel like this would be a utility, maybe a little bit more. Like if I head over to utilities and we just have our all items same length. we're going to take in an item or a list, which in this case, we know it's going to be strings. So you're going to be string, and we're going to return a Boolean if they're all the same length. How are we going to do this? I guess we can for loop through this. We can grab the first. We can grab the first one. So let so like the target length. So like the first length. We can just get. We assume that the list has items in it, right? Otherwise, it's empty. I wonder if I should I bail? I could bail and make this a result. So result the boolean inside. So if the list dot length, if that is if the list is empty. Okay, so if the list is empty, then we're just gonna bail. We're gonna bail because list must not be empty. Okay, now we know it's not empty. So let's just get the first one. We're gonna say the target length that we're checking for is list of 0 dot length, and then we just loop through this. So for item in list, and we just check to see so if the item dot length is not equal to length. I don't care that I'm also checking the first one. That's perfectly fine. If it's not equal to the length, I return false. We return early with false, and if we get to here, we return true. So we return okay, true, and okay, false. Okay, so are all items the same length? So if we get down to this point, we have multiple possible commands, and we want to check to see if possible commands, or actually I should do it the other way. If all items are the same length, pass in the possible commands. If they're all the same length, we ring the bell, which means we have to know if we're in a bell state. Okay, we have to know if we're in a bell state. Can I see what the last one is? I don't think I can see what the last thing that we printed out is here. Okay, so this would be out here. So let mute in bell state. We're not in a bell state. The only time that we care about a bell state is for this thing here. So, I guess this is autocomplete. This is autocomplete bell state. So, autocomplete bell starts with false. If we get to here, if all are the same length, we then also check if autocomplete bell, if this is true, we've rung the bell before. Otherwise, we want to self dot print the bell, and autocomplete bell is now true. And so if we get here, autocomplete bell becomes false again. We want to get the list of possible commands to complete. We want to sort them. So possible commands, you need to be mutable. So we sort you now. Possible commands will sort you. I want to join these and then print them out. Let's see. Joined possible commands. I might be able to just actually print this out in a new line, right? Oh yeah, and so like that's where this gets really interesting too. I want to hit return, so we want to. Oh, okay. This might be easier than I think. I want to print a new line, so we're just gonna do self dot term right line with nothing in it. I don't have like a new line, right? Yeah, I didn't do that. We're not that insane. We write a new line. I then want to write all of the things out. So we're going to write self term. We're going to write this, and then this is going to be the possible commands that we're going to join together with 2 spaces. And then that flushes out, and we can continue. No errors. Let's see if this works. So if I do XYZ, we get the bell and we get those printed out. Oh, and then I forgot. So we write this, and then we want the next prompt to show up again too. So we self dot term write line again, and then print the prompt. Self dot print prompt. Okay, XYZ. So bell, do that, and now we can continue trying. So we can do oh, and I think we want to print the prompt. Oh, we just reset the line. Self dot rewrite the line with user input. I think that's what we wanted to do. So XYZ, there you go. Now I can continue writing this. So I could do dir, that's still that, and then it auto completes. Okay, I think we have that running now. So this is handling auto completes when there are multiple possible completions that are the same length. Okay, so I think that's multiple completions. And then finally, the last one is partial completions. I have to do this one first because I think all the tests won't really, none of these will be testable until we get this one working again. So now we know that they have different, different sizes. So now we need to calculate the LCP for each of these. And in utilities, we have, let's see, all matching commands, LCP the same. No, that's not what I want. Ooh, where do I calculate the LCP? Oh, don't tell me I just put it into here. I think I did. I just put this straight into here. So I need to calculate. Okay, so pub function, add LCP. So add LCP to list. We're going to take, I guess we're not adding LCP. Let's just say calculate LCP, which is longest common prefix. So longest common prefix. We're going to take in our list, which is going to be this, and we're going to return a vector. And I'm okay with doing this as a tuple again. Let's do the LCP. This is I forget what we had to do before. If it had to be usize and then the string. Okay, so how do we do this? We have to compare one against all the others. No. It's simple. We have our comparator. So basically we have our word, which is a stir, and then we have our list. And so we just want to get how long after the word is matched. So that's just a simple map. So we can just take our list, and get an iter. We can now map. We're gonna get this is the list word, and we want to remove, to strip out. Okay, so we need the word length. So this is the remaining word. So is going to be equal to the list word we can get, and it's going to be the word length to the end. Stop it. Don't do that. Okay. So we get the remaining word length into the end. This should exist because we know, well, I guess like word length, technically it's possible that it's not. I'm going to filter map here to make it a little bit easier. So filter map, which means we can question mark u. That gives us a string, and then our LCP is going to be equal to the remaining word length, and then we're going to return a tuple of the LCP and the remaining word. We can to-owned you, and then we can collect you. Yes, I need to be some. Okay, so this gives us the longest common prefix here. So get user input. Okay, so all items are not the same length. Therefore, I need to get the possible commands with the LCP. So this is now going to be let possible commands with LCP. Was it calculate? Longest common prefix. We have our word, which is the user input. We have our list, which is possible commands. Okay, so now we have our possible commands with LCP. I want to sort these by usize. So let's make you mutable. We're going to say possible commands with LCP. We have to sort by. We have our functions. We have A and B. And we want to say A dot 0 dot compare to B dot 0. Okay, so now we've sorted the possible commands and we now loop through these. Okay, so now we loop through these every time we press command and we print it to the we have to reset, but we need to know that we're in this state. So this is going to be okay, so we're only going to be working in here once we get in here for this is going to be mute auto complete LCP essentially, and we'll set this to be an empty vector, and that can also be our flag for this. And so here is if it's empty, as in we haven't done it. So if autocomplete LCP is empty, I want to grab you and then we sort you. We also need an index for which one we're currently in. So let's mute autocomplete LCP index. We set you to 0 and then we reset you. So autocomplete LCP index equals to 0, and then we're ready to continue on. So if we're empty, we set that up, and now we move on. This is because as soon as we hit space, we need to reset this too, don't we? So before I forget it, if we hit the space character, in command is false. Oh, in command is false. So we might be okay with this. This just might work. All right, 5-minute warning until a new an ad break, but that'll be the last break of the day. So we'll go ahead and take that. So what are we going for here? I want to, if autocomplete LCP is empty, we fill it. And it's always empty to begin with. So we only get here, I guess if I backspace, that might screw things up too. I don't think if I backspace, we should also reset. I mean, I don't know. I mean, we're doing so much stuff that's just for these tests. Let's just only do that if we absolutely need to. Okay, what are we doing? How are we doing this? All items the same length. No, I just read that out loud. My brain is clearly starting to get tired. We're auto completing. We're now looping through the potential auto completes. So when I press tab again, I should tab to the next item in the list. So the next item in a list, we grab this out and then increment our index. So let's I wonder if we should do an iflet and I get it by that. Iflet sum, this is the next possible command. Possible commands, what did I assign this to? Autocomplete LCP is empty. Possible autocomplete LCC, we calculate that. We sort by, and then I do need to save this. So this is going to be autocomplete LCP equal to the possible commands with LCP. I can strip this out, can't I? We can do an into iterator. We just map you. We have I don't care about you, and this is the word, and I just want to return the word, and collect you. I think you'll figure out what type you want to be. Okay, so this is autocomplete LCP. You want to get from the autocomplete LCP index. I now have a reference to the string, which is perfectly fine because we can to-own this. We get the next. Okay, so we've got the next auto. We're going to now set user input equal to next possible command to own that. We also want to auto increment our index. So let's do autocomplete LCP index equal to if autocomplete LCP index, if that is equal to autocomplete LCP, autocomplete LCP dot length -1. Okay, so if you're equal to that, then we return 0. Otherwise, return autocomplete LCP index +1. This is the worst. These continuously get worse and worse as we go down, and we're still in it. So everything else should remain the same, I think. Oh, and then after we do this, so next possible command, autocomplete. So we do this. I then want to self dot rewrite the line with user input, and then I think we can continue because we're still inside of this. So let's check to see if this works. Okay, so if I do, oh, that was weird. That was a really weird state that we got into. What happened? It shouldn't have reset that. I wonder if I need to okay, so if it's empty, we should get all this in here. So I kind of want to print line. All right, so auto complete LCP is empty. Oh wow, the ad break happened. Oh, I wasn't paying attention to that. Sorry. I thought it was still counting down to when it was going to start, not like the ad break had happened. So sorry about that. And apparently I am not taking my break. So now we're on until noon or so. Okay, autocomplete LCP is empty, and I want to take a look at autocomplete LCP. So if I do bash, okay, autocomplete LCP is empty, but there's an H. Oh, because of bash, because I actually lost. Oh no. Okay. I did this so wrong. I didn't want to actually remaining word. Okay, hold on. This is the actual word that I want in here. So LCP is that, but not the remaining word. I want the list word. Otherwise, it just gets weird, which is what we saw. You didn't get any? Well, that's perfectly fine. I don't complain if nobody got any ads. Okay, so bash base64. That tabbed auto completed because there was no other base64 that starts with that. But in this case, if I'm in this mode where there's autocomplete LCPs, then we don't do tab autocomplete we don't do these. Okay. Which might make it more sense to then check here. So if it's not empty, we do this. Not scroll down a bunch. Okay, so if it's not empty, we're gonna do this. Okay, so we're still in command. So if autocomplete LCP is not empty, we do this. Otherwise, we continue on. So then this should now tab through them all, even if it goes to like base64. So if I do bash again, bash base64, oh, it still completed it. Well, because it recalculated it again? When did that? Okay, so it wasn't empty again, so it kept it. I hit tab, so let me try print line. Running through possible auto completes. Oh, type annotations needed. Why? Fine. You're gonna be a vec string. Okay, so if I do bash like that, it's empty. We have bash running through possible autocompletes. Did I just do the thing where I didn't save it again? I've done that so many times. Okay, you're saved. Okay, let's also get rid of this other write line or print line. Okay, bash base64 bash bug base name language server, and then back to the beginning again. And then if I do like that -h, let's say, I get the output. Okay. Now the other ones should still work. XYZ, excellent. And then echoes just I wonder if this is gonna work. Let's find out. Commit. Okay, so refactored user input. All the other what did I call it? Oh, I should make this big. Closed. So this is partial completions, which is this one. Okay, so available executables are not all the same. So partial completions, we type, okay, so it received the prompt, it typed XYZ underscore, it pressed tab expecting, oh, because I believe that I need to go to the next index right away. Because I need to match with the first thing immediately, or I need to match with you here. Okay. So if you're empty, before we exit and we continue, I need to set the index to +1 already, get the first, and then increment. In an iterator, is it possible to do like a forever iterator? It doesn't go into the first ones, right? I think it doesn't do a loop around. That would be really cool if I could. Like if I could do something like instead of storing the actual array, if I stored the iter over it, then I could do autocomplete. So if I do autocomplete LCP, let's get an iterator. So I can do next, removes and returns an, oh yeah, I don't want to remove. Repeats an iterator endlessly. Instead of stopping at none, this iterator will instead start again from the beginning. After iterating again, it'll start at the beginning again and again and again forever. Note that in case the original iterator is empty, the resulting iterator will also be oh, okay, so I think this is what I want. So I can cycle. So autocomplete LCP, if I just don't set this right now, if we get to this point, possible commands with LCP, I map out and remove that. And what if I just don't collect you? So you're just eternally an iterator with the word. So we have that. And then I want to set user input. Oh, we have to do an iflet. So iflet sum, this is going to be the word equals autocomplete LCP. That's the examples. Cycle. Oh, next. Okay, so that's not how it works. I do this and I cycle that. I cycle there. Now I can get next here. Okay, so if I get a word, so I get the first word, which is next, we set this. So user input equals to the word. I want to self rewrite the line with user input, and then we're done here. We come back to the top, and so it's not going to be if you're empty or not. Should you be an option? Maybe you should be an option because you could be none. Then I have to set what you are going to be, and that sucks. It looks like I have to set you anyway. So I can do impl iterator item strings. This might be fine. So if I just say you're an iterator, well, actually, if I just say you're an option, no, you're a none, but you need to know you're an option with a iterator. Can I do the impl? No, you do not like that at all. Maybe you do. Iterator item string. Ah, okay. What exactly is this type? Oh, all I see is impl iterator. It's a trait. It returns a cycle. I have this map into iterator. I wonder if this is what I want. I wonder if that's what I want. Let's see. So your type would be, can I just do that? Will you be happy? No. Ooh, what type are you? You're not an option iterator. You're not a result. I think you're an array. Ooh, but I think you're a vec into iterator. Okay, so if I attempt to get the next thing and I fail to, that's because it doesn't exist. So I think I can just do if let sum is now the word equals autocomplete LCP. We get the next thing. If we get that, oh wait, it's sum and. Oh, hold on. This is gonna be how do I do this? I think it's is some add. So if let some word if I don't know. If autocomplete LCP is some and that just booleans that. I guess I could let's see, and won't help me there. I don't want to insert or do anything like that. I want to get it out. Map won't be good because I don't want to change it. Wait, is that true? What I do next, that does change it. So I do want to map it, but then I'm in a closure. And can I update this inside the closure? I don't know. I think it might be better for me to just do if let sum. So this is going to be the this is going to be just our vector. So it's our matching word list, matching words, autocomplete LCP. Let's see. Then I could do next. So if let some the next word was matching words, give me the next one. So if we get you, I want to set the word. So user input equal to the word. We want to, I'm guessing I'm going to need to clone you. It should yell at me. We want to self rewrite the line and then immediately continue. And none of that matters. We're done with you. So significantly easier. I'll rewrite the line with user input. Okay. If autocomplete LCP is empty. Okay, so this is none. And then the rest are true. You need to be auto. It's going to be some. What are you upset about? I can't get the full error here. Let's try running it and get the error here. Okay, so get user input, autocomplete LCP, some possible commands of the LCP into iterator cycle. Okay, so expected a map into iterator use size found cycle map into iterator. Okay, so do I just need to add cycle into our fun list here? So option maps here a cycle map into iterator, bring you in. Okay, so now your if let some okay, so we know that you have something in here. So this is one of the few times where I can just really safely unwrap. Why did you okay? Don't unwrap and then call next. We still have errors. If let some matching words equals autocomplete LLC. Okay, so use a moved value. I don't want to take ownership of you. So we borrow you. You're saved. Cannot borrow you. I don't want to take ownership. I want to clone you. Type annotations needed to owned. Whoa, I've never seen type annotations needed for word. But I know word is a string here. You can see it. So it can't infer type of to owned. Can I just say that you're a string like that? To feel. Okay, what did I get myself into here? Let's see. Yeah, so I want to clone, but clone still requires type annotations for some reason. Hold on, let's try get rid of these other warnings too. I don't need those two things. Okay, so user input is a string. We know that it's a string. Word here is a string. Like you know that it's a string here. Yeah, what the fuck is Rust smoking here? Yeah, exactly. Okay, so Rust Analyzer knows that it's a string, but apparently Rust does not. The compiler does not. So when I get next out of matching words, and if I do that, that just moves the error down here. Okay, so word type notifications are needed. What is the type of autocomplete LCP? Autocomplete LCP is a option cycle map into iterator. Um, oh, usize and string. Why is it usize string? Oh, I know iterator is usize and string, but when I get next out, I should just get the string out because it's just a vector of strings at that point inside of everything. I know I've got a monster type here. Okay, this is the problem with dealing with iterators is you get monster types like this. Okay, so if let sum word equals, so matching words next. So next gives me an option with then the item inside of it, which is a string. Now, if I say, hey, word, you are a string. Oh, so wait. You're not a string. I'm so confused. So I get the word here. I can't infer the word type. Okay. Can I do string from word? Okay. Let's borrow. Oh, cannot borrow matching words as mutable. Oh, right. Because it needs to be borrow a moved value. Oh, so this is, why is this a moved value? Move occurs here. Uh, well, because it's set initially here. I want it. Yeah, you're fine, right? So autocomplete LCP, I do this entire thing. Oh, do I just need to set you that you're a string? But yeah, it can't borrow you. Yeah, okay, so we have problems. I'm using a move value because in this point, I'm in a loop. I'm in a loop at this point, which means I okay, so if let sum I want to borrow you out of here. Can I think we can do that, right? So we can get an as ref or I can get an as mutable ref. So I can do as mute like that. I mean, if I just do as ref, next does okay, so next does mutate that because it's an iterator. This needs to be as mute, borrow move value. So okay, these two errors are exactly the same. So it's two errors in one line. And then I no longer need you. Okay. The move occurs here at the beginning of the function. I don't understand that. Inside of this loop, consider calling. Okay, so autocomplete LCP moved due to this method call in a previous iteration of the loop. So, oh, because I unwrap it. So I want as mute here. Then I can unwrap. There it goes. There we go. We got it. Okay, that was a lot. I want to do that. I want to no longer be in full screen mode. Let's try this again. So cargo run. Okay, so if I do bash, we go through all these different things. I want to do, let's say, base 64 space. Tab doesn't do anything at all, but that's fine. That gives me there. If I do type echo, if I do echo, that just auto completes there. If I echo hello, if I do XYZ, okay, this might be working. Okay, so storing a cycled iterator for potential matches. Let's see if these all pass. Oh, okay, so it came close. What happened here? So we got the prompt. The prompt line matches. Okay, so it prompt line matches that. They pressed tab. It then went to cow. they pressed, oh, they typed underscore. When we type underscore, it should reset all of these things. So we need to reset user input. No, we need to reset autocomplete bell and reset autocomplete LCP. I think the only one we really need to reset is autocomplete LCP. So when we type anything, so we write that if the character, yeah, so no matter what this is, we can just say autocomplete LCP becomes a none. I don't know the best ways to test for that. So let's just commit it. What is this going to be? This is going to be when typing, we reset autocompletes. So yeah, okay, everything's working. The post refactored is still pretty like a pretty big beast, but I feel like it's a little bit easier to manage now because it's not like it's got some nested ifs, but it's nowhere near as bad as the previous one. So the fun things that we can do with this, get user input, I can close you now, but this get user input, I don't think is ever, yeah, this is never, to go to references, never used. So I can get rid of you completely, which is always nice. Git command now takes in what that, it now figures all that out. Could I do a bunch of things there? I probably could. I probably should, but after this basically full stream of rewriting this, I am okay with not. Okay, let's commit. We rewrote the user input. I guess like removed the old. We removed the old user input. 130 lines. I wonder how much our other one was. It's probably more lines because I broke things out a little bit more to be a little bit easier to see. But okay, everything is working just fine there, which means we can now proceed to the next step, mark the stage as complete, and that is all of auto completion done, which means that we're now onto pipelines. So we have pipelines, history, and history persistence, which is so much nicer.